Well, hello, ladies and gentlemen. Hello, ladies and gentlemen. So, looking at the time, it is late. It is 4:30. The sun is starting to go down. It's going to be dark by the time I get home. But unfortunately, this is the very first opportunity I've had since class to sit down and do the shortest distance questions for you. And I did promise them to you today. So, what I did decide is that I would do a video for you and put it up. Now, what I'll also do is I'll take the PDFs of this video and put it up for those of you that don't want to sit through my ramblings and you want to get right to seeing what's going on here. But others of you will appreciate the ramblings, and here we go. Determine the shortest distance, sometimes just called the distance, from a certain point, and in this case they're giving me a point, 5, 13, to a line 3x plus y minus 15 equals 0. So I'm going to use a little bit of grade 10 knowledge. You know what, it might be grade 9. I'm going to take this equation of the line and I'm going to find my intercepts. So if I let x be 0, then I know y is going to equal 15. And if I let y equal 0, I know that x is going to equal 5. So what that allows me to do is come over here and pretend that this is going to be 5, 0. It's a good pretend. And, I don't know, let's throw it up here somewhere. Let's pretend that this is going to be 0, 15. And let's connect these guys with a nice little line. There we go. And let's pretend it's a line so it keeps going in both directions. And so what we have now is we have taken, I should just be able to do this, duplicate it, put this over here, and I have a rough estimate of that line. Now, what we're supposed to do is take this point right here, and we're supposed to find the shortest distance between that line and the point. Well, the first thing I better do, now think about it, kids, I better make sure that the point doesn't lie on the line. Because if the point lies on the line, then the shortest distance is 0. So I'm going to take this point and check to see if it lies on the line. And I'll do that by, I don't know, throwing the point into the line and seeing if it satisfies it. And as we can tell, that is not going to satisfy it, so the point is not on the line. So now that means the point's not going to be on the line somewhere. And if I want an accurate diagram, I got to figure out whether it's going to be above or below the line. So for this point, when x equals 5, y equals 13. For my line, when x equals 5, I'm going to get 15 plus y minus 15 equals 0. I'm going to get y equals 0. So this one's going to be 5, 0. I guess we knew that already. And this one's going to be 5, 13. That was kind of really dumb of me to do. I'm a little embarrassed by that. So I'm going to be about here. This is going to be my point, 5, 15. Okay, so now I have a good idea of what I'm looking at. Let's make some room here. I'll grab this and I will cut it, and then I will paste it, but I'll make it small so it's up and out of the way. Isn't that cute? And using the magic of Apple, we will grab this and we will cut it and we will paste it and we will make it nice and small. Isn't that a beautiful thing? Okay, let's get it up and out of the way. Yep, up and out of the way. I got this little extra part up here. It's kind of yucky. Let's get rid of it. There we go. Look at that. Oh, Apple's a wonderful thing. I got a little extra part down there. Yeah, now I'm just fiddling, I know. Okay. All right, so what are we doing here? We're trying to find the distance between this point and this line. That distance, well, that is anormal from the line. It is anormal from the line. There it goes right through there. And what I'd like to do is I would like to create a vector that goes from, you know what, that's not the best color, but I'll change it in a minute. I want to go from a point P on the line. So I'm going to go from a point P on the line to my point Q, which again is right here. So I want to go from some point on the line. Now it doesn't matter. Could be a point here, 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 could be a point here. It really doesn't matter, but I want to create a vector that goes from a point on the line to the point off the line that I want to find the distance. Now I'm going to change this color so it's kind of pretty. So there we go. And I'm going to call this point, I'm choosing to call this point down here A. And I could have chosen any point that would satisfy, that would lie on the line, but I happen to know A is 5, 0. So what I'm going to do is I'm going to create AQ. Well, look at that. I called it A, and everywhere else I've called it P for point on the line. Look at me go. So there's P. So I'm going to create, goodbye, I'm going to create the vector PQ. And that's going to be the one that's going from P to Q. And it's right here. And so that would be this vector. And so PQ is going to be determined by PQ is going to equal P to O, wherever that might be. Well, I have it there in the diagram, plus O to Q. That's how we add, that's how we create a vector in space. And then it's going to be OQ minus OP. So it's actually going to be OQ, which is 5, 13, and OP is going to be 5, 0. So I'm actually going to get 0, 13. That is my vector PQ. Now remember, that means that my vector PQ is 0i plus 13j, and it's actually here, right? So it's the same vector as this guy here. All right, so now I have PQ. So what I want to do is I want to find the distance between my point and my line. And that's going to be a perpendicular distance, always, always, always. Look, this distance is farther away. This distance is farther away. This distance is farther away. The shortest distance is going to be right there. And then it's going to get larger and larger and larger, the distance between any points on the line. So what I want to do is I want to find the component of this vector that is perpendicular to the line. So the component of the vector from a point on the line to the point off the line, right here. And we've done some work on that. We know that that's a projection. So what we're actually doing, what's this doing down here? Let's have that. Oh, it bounces. That's kind of cool. I like that. All right, back. So I'm going to grab a color that I'm happy with. So I'm going to project PQ onto the normal. Now, this normal, we know a little bit about that normal because we know the scalar equation of the line. So that normal is going to be given by 3, 1. That's the normal. So the normal is going to be given by 3, 1. So the projection of PQ onto N, when we go to do this, is going to be equal to PQ dot N over top of the magnitude of N, because that is the projection that we worked out earlier in an earlier unit. So what do we have now? We've got PQ is going to be 0, 13 dot 3, 1 over top of the magnitude, which is going to be 9 plus 1. So now I've got 3 plus 13 over top of the magnitude of 10. So the shortest distance between that point and the line is going to be 16 root 10. Now, to be honest with you, that's not a bad way to write the answer. However, for some reason in high school, I'm not sure what the reason is, we insist that you rationalize denominators. And I mean that. I really don't know what the reason is anymore. It's a dead skill. It's not needed anymore. So it's 16 root 10 over 10. So it's going to be 8 root 10 over 5. And it's also going to be 8 times 10 square rooted equals divided by 5. It's going to be approximately 5.0596 units. And you could go as far as you wanted with that. But that's what we did. That's how I find the shortest distance from a point to a line. And it's all about finding that and understanding that that is always going to be a perpendicular distance and coming up with a vector from the line to our point, and we simply project this vector onto the normal. And if we think about it as a projection, then we use that formula. And if you didn't want to use that formula, then you would do a bunch of work and you would come up with, like this is a right triangle. You're capable of doing it from first principles. It's just not a lot of fun. So, there you go. All right, the next one. So now we're just going to apply the same idea again. So I would like to find the minimum distance from the point 1, 3, negative 2 to this plane. And I've got a cute little diagram out there this time. So the first thing I better make sure is that my point doesn't lie on my plane. Because if my point lies on my plane, then what I'm going to find out is that the minimum distance is 0. Because the point lies on the plane. So the distance between them is 0. So let's see. Does Q lie on the plane? So it would be 4 times 1 minus 3 minus 2 plus 6. And that would be 4 minus 3 plus 2 plus 6. And it does not equal 0. So no, it doesn't. No, it does not. So that's convenient. Okay, so there is a distance between the two that is not 0. Well, that's a good thing. Not a good thing or a bad thing, it's just a thing. So here's Q. Q's out here. Look how cute Q is sitting out here in the space here. And I need a point P, not. It doesn't matter what point. I really couldn't care less what point on the plane I use. I just need a point on the plane. So, I don't know. So choose, and I mean that, choose P naught on the plane. It sounds like peanuts, but it's not. It's P naught. Okay, on the plane. So anything that'll satisfy this equation will work. So how do you feel about 4 times 1, that's cool. And how do you feel about 4 times 1 minus 2? So that'll give me 4 plus 6. I don't want to be plus 6, I want minus 6. Okay, so let's make that negative 1. Let's make that positive 2. So that'll be negative 4, negative 6. I got rid of my 6 up above, so my z can be 0. And plus 6 equals 0, at least I think it does, negative 4, negative 2, plus 6. Oh, look at me go. So that point, negative 1, 2, 0, lies on the plane. The plane. So I'm going to call it P naught. Again, that's funny. All right, let's make this a little bit smaller. Magic of Apple. So I've chosen P naught. All right, so guess what I'm going to create? I'm going to create P naught Q. I'm going to make this vector. I'm going to make that vector, okay? So P naught Q is going to be, I don't know, P naught to O plus O to Q. Look at me go. It's going to be O to Q minus O P naught. And so OQ is 1, 3, negative 2, and P naught is negative 1, 2, 0, and it's 2, I hope I'm not making a mistake anywhere, and it's negative 2 minus 0. So if I make a mistake, someone send me an email before I leave this up all night. Okay, group, yay, I got P naught. So actually, let's go back. What am I doing? I can just see someone, what is he doing? What is he doing? Okay, so what I'm doing is I'm looking at the normal to the plane, okay? My normal to my plane is going to be a perpendicular, and that is going to be the shortest distance to that point. The perpendicular. Take your hand, hold it above your desk, and start dropping lines down to your desk. You're going to notice if you drop a diagonal line from your fist above your desk over to the corner of your desk, that's going to be a length. And that length is definitely going to be longer than if you take your fist above your desk and drop straight down to your desk. That perpendicular distance is going to be the shortest distance from your hand above your desk down to that plane. So that's what I'm doing there. And so what I'm going to do is I'm going to make use of this idea that I'm going to think about the projection. I'm going to look at the projection of PQ, P naught Q, on to the normal. That is my shortest distance. It's the projection here. Okay? That bit. Let me get a cute little, here, this part. So the projection of this vector onto the normal, which is just that, oh, too much. It's just that little bit. Okay? All right, so how do we do projection? How do you do the projection of P naught Q onto N? Well, it's P naught Q dot N over the magnitude of N. And we worked that out in an earlier unit. Oh my goodness. So what have we got here? I got this going in there, but what's the normal? What's the normal? Well, that's not hard. Go grab yourself the plane, and you're going to take that and you're going to come up with the normal to the plane. And the normal to the plane is given by 4, -1, -1. So I'm going to take that and I'm going to throw it up in there. And then what about the magnitude of the normal? Well, that's not hard. That's going to be 16 plus 1 square rooted. So that's going to be 17, 18, the square root of 18. And last time I checked, that was 9 times 2, so it's 3 root 2. Look at me go. All right, so let's put all of that where it goes. So now, and look, I'm after a length. So it's going to be in terms of a unit of some sort. So P naught is going to be, where are we? 2, 1, 0, dot. 4, -1, -1, cool. All over top of 3 root 2. All right. So it's going to be 8 minus 1 over top of 3 root 2. So it's going to be 7 over 3 root 2. And again, I have no idea why we make you guys do this in high school anymore. That's a personal pet peeve of mine. So it's 3 times 2. So it's going to be 7 root 2 over 6. And just in case anyone doesn't know how that happened, what we did was we rationalized the denominator by multiplying by 1. And again, it's a lost art. We don't really need it. But again, I am showing my bias and nobody wants to listen to that. So let's see what we got. 16! 1.6, not 16, as a liar. 9915823, and that's where my calculator sort of loses it. So units, whatever those units might be. And again, I have to be honest with you. This is ugly. This is glorious. Moving on. All right. Oh my goodness, can we figure out the distance between two planes? I don't know, maybe, I don't know. Let's look. Let's say I find a point on this plane. Let's call it, oh, I don't know, how about point naught, P naught? No, that's too obvious. Let's call it A, A. And let's call another point down here B, okay? Okay. Now, notice I didn't put it directly underneath. Okay. It might be directly underneath, and that would be great if I could find it. And if I did go directly underneath, then this line would in fact be a normal that passed through both lines, and that would be a lovely thing. But hold on here. Where's my, just want to make this pretty. Whee! Kinda. Yeah. Let's move this over. Okay, so that's going to be a normal whee to both planes. And that's a beautiful thing. That's a beautiful thing. And guess what? If I take the normal from the first one here, this normal is going to be 2, -1, -2, and this normal is going to be 4, -2, -4, which, by the way, kids, those are the same normal, right? Because it can be reduced, they're scalar multiples, so there you go. But what I want to do is I want to create that vector. And that vector is the vector between some random point on the first plane to some random point on the second plane. And my minimum distance between the two planes is going to be that distance. The distance coming up from the one plane until it hits the point on the plane. Remember, planes don't have thickness. There's no thickness. This is a completely flat without thickness here. So it doesn't matter when I hit this point and to hit this point, that is the minimum distance between the two planes. Well, okay, so what that looks like to me, and I don't know, does it look like to you? I hope it looks like it to you. But if I'm looking for a vector AB, well, you know, that would be coming this way. And that's fine. That's fine with me. So vector AB, if it's projected, if I project AB onto the normal, I'm looking at the minimum distance. That's what I see. Do you see? I see. So the projection of AB onto N is AB dot N over the magnitude of N. Again, we've been doing this 1,000 times. So AB, there's a wrinkle. There's a wrinkle. I don't know what A and B are, but remember how I built them. They're random points on the plane. So random points on the plane. I'm going to grab this one, and it's a random point on that plane. And this one, and it doesn't really matter which one's on top of which, because I could always change my perspective and be standing on my head, in which case they would be right if they're actually wrong. It wouldn't matter. But for A, why don't we come up with the points? How do you feel about -1, 1, 0, kids? So that'd be -2, take away 1 is -3, 0 z's. It looks good to me. And this one, how do you feel about, ew, yucky. Yuck. So it's going to be, let's do 0, and let's do -1/2, that'll be 1, and let's do -2. Let's see if I did it. So that would be 0x, that would be -1, and then it would be -8, -1 and -8. Oh, that's going to be +8, that's bad, make it positive. So that's going to be, no, I was right the first time. Goodness gracious, silly me. So that's going to be +1, that's going to be +8, and that's going to, the -9 is going to make it 0. Yay, that's a good thing. So AB is going to be A to O plus O to B is going to be O to B, subtract OA. So it's going to be 0, -1/2, -2, and no, I can't change that. That's a point. We're going to leave that. We can't multiply through by 2. And we're going to subtract -1, 1, 0. And we're going to get 1. And we're going to get -1/2 subtract 1. So it's going to be -3/2. And it's going to be -2. Okay, so that's AB. And looking at N, we had already figured out what we thought N should be. We might as well take the simplest N, which is 2, -1, -2. The magnitude of N will therefore be 4 + 1 + 4, so that's 9. Ooh, looky, looky. That's going to be 3. That's kind of cute. Let's put in everything where it goes. So it's going to be 1, -3/2, -2, dot 2, -1, -2. Let's move that over. Let's put a line. Let's get 3. So it's going to be 2. -1 times -3 over 2 is going to be +3 over 2. -2 times -2 is going to be +4 over 3. So that's going to be 6 plus 3 over 2 over 3. Getting a common denominator in the top, it's going to be 12 plus 3 over 2 all over 3. So that's going to be 15 over 2 over 3, which means 15 divided by 2 divided by 3, which is 15 over 2 times 1 over 3. So it's actually going to be 15 over 6, but you know, come on, let's get real. There's a 3 there, there's a 5 there. So why aren't we reducing this to a 5 over 2 immediately? And that's units. And yeah, sure, change it to 2.5 units if you must. And that's the shortest distance between the two of them. Isn't that cool? That's kind of cool. Anyway, I think I'm done. I'll look for some homework for you. You can look through for some homework for you. Do these questions. I'll post a little bit more when I find some homework, and that's it.